Assalamualaikum, my name is Nomid Ahmed Pracha and my roll number is 180931. Here in this video I will present our microcontrollers and embedded system lab presentation for final project, which is considered as lab final and lab mid. Here in this simulation we have used three logic states which are considered as IR sensor. First logic state is considered as right IR sensor, second logic state is considered as center IR sensor, and third logic state is considered as left IR sensor. After that we have used Arduino Mega for our simulation. Then we've used a motor controller to control our motors. Motor controller name is L298N, and then we have used two motors with LEDs. Then we have used a temperature sensor to display the temperature. Then we have used a hurdle sensor, a potentiometer which is considered as a hurdle sensor, and then LCD to display all the commands. If we go to the code of our project, this is the code of our project. At the start of this code we have defined the crystal frequency for our controller. Then we have included library of input and output library, then delay library and interrupt library. Then we have added this LCD library to display all the commands on LCD. Then we have defined the pins for our three IR sensors, and then we have defined our motor driver pins. After that we have defined some functions. In first function we have defined a function for named as motor 1 for controlling the speed of our motor 1, in that function we have saved the value of duty cycle in percentage in OCR0A for controlling the speed of the motor, and same for the second motor, which is saved in OCR2A, OCR register, output compare register of timer 2. We have used timer 0 and timer 2 because both the timers are 8-bit timers. And then we have initialized the timer 0 for motor 1. In the initialization we have to use fast PWM mode, and we have to compare the output, compare the output match, and that's why we have make these three pins high: COM pin of motor of TCCR0A register, and WGM00 pin and WGM01 pin. These three pins are made high. Then we have made CS00 of TCCR0A high to run our timer on prescaler mode, on no prescaler mode. The same is the case for timer 2 to control our second motor. Timer 2 is also run on fast PWM mode and on no prescaler mode. And then we have defined the function for forward movement of the robot. In that function we have made these port H pins. If I will go to the main code, I will tell about some pin definitions. We have made DDRF as output, means port F as input for left sensor, left center and right IR sensors, and temperature and hurdle sensor. These are analog inputs. Then we have made port C as output for LCD pins, LCD data pins, and then I have made port B 6th and 7th pin for RS and enable pin of LCD. Then I have made integer int1, int2 and int3 and 4 pins of port H. These pins are defined at the start of the function. int1 2 and 4, 3, 4 and 5 pins of port H. We have made these pins high as output, considered output for motor driver. Then I have made enable pins high, which are 4 and 5 pin, I think. 4 and 5 pin of port B. Then we have made these pins high. If we go to the function, this is the forward movement function. In forward movement function, we have made one pins of both motors high to make the motor run, and then we have gradually increased the speed of the motor 1 and respectively the speed of motor 2. Here it is motor 2. And then we have displayed that forward movement on LCD and then cleared the LCD. Similar case of right movement. In right movement, we have made one pin of motor 1 high, and which is in 1. Then we have gradually increased the motor 1 speed and gradually decreased the motor 2 speed. This is gradually speed decreasing and increasing is done to make the motor movement of our tires gradual, a smooth movement of our tires. Then we have displayed this right movement on LCD and then cleared the LCD. After that, left movement of function is defined. In that function, we have made one pin of motor 2 high, which is in 3, to make only one motor run, and then we have gradually decreased the motor 1 speed for smooth movement of tires, and then gradually increase of motor 2 speed. After that, we have displayed that left movement on LCD screen and then cleared the LCD. After that, we have defined a stopping function. This function is used to stop both the tires of the robot. In that function, we have made all the pins of port H low so that both the motors pin become low. Then we have gradually decreased the motor 1 speed and gradually decreased the motor 2 speed, and then displayed that stopping function on LCD and then cleared the LCD. After that, we will move to main function of our project. In main function, initially we have defined two integers, integer variable for our temperature sensor and hurdle sensor values, and then we have converted defined two character type arrays, both of 10 size, to save the values of temperature and hurdle sensor. Here it is hurdle sensor. After that, we have defined the input directions of pins, which we have discussed before. Then we have initialized the LCD. Here is the while loop. In this while loop, firstly we have checked if center sensor is 1, then we will move forward. If only center sensor is 1, all other sensors are 0, then we will move forward. Else if right sensor is 1, then we will move to right, and if right and center both sensors are 1, then we will also move to right. Then if only left sensor is 1, then we will move to left. Then if left and center both sensors are 1, then we will also move to left. And if all the three sensors are 1 or all the three sensors are 0, we will stop our robot. After that, we have initialized or we have done initialization of our ADC register, ADC analog to digital converter. Firstly, we have done this for temperature sensor. We will write here for temperature sensor. Firstly we have in AD mux register we have made AVCC with external register at a reference pin and selecting the third channel of ADC, third channel. Then we have in ADC SRA we have enabled the ADC, and then we have enabled the interrupt of ADC. Then we have pre-scaled or clocked to 128 frequency, so that as we know that our analog to digital converter only works between 50 to 200 kilohertz frequency. So making our 16 megahertz frequency between 50 to 200 kilohertz, we have pre-scaled or clocked by 128, so that our crystal frequency will be divided by 128 to make it between 50 and 200. If we will divide 16 megahertz by 128, then it is 125 kilohertz, which is in between this 50 to 200 kilohertz frequency. Then we have displayed this value temperature on LCD, which is coming in the temperature value is coming in the next steps. Okay, then we have enabled the ADSC pin of ADC-SRA to start the conversion from analog to digital value. Then we have stopped here. In this condition, we have checked if the conversion is completed. Until or unless the conversion is not completed, we will stop here. When conversion is completed, then we will clear the interrupt flag. Then we will convert the temperature value which we will get into value from ADC into digital value. Then we will use ITOA function. This function is used to convert the integer value which we get from analog to digital converter, which has taken analog value and converted it into digital integer value. By using ITOA function, we will convert that integer value into character array of 10 size, as our analog to digital converter is of 10 bit. Then we will display this character array on our LCD. Then we will display this unit, and then with some delay we will clear our LCD. After that, we will done the same step for hurdle sensor. Basically, hurdle sensor is we have used a potentiometer for hurdle detection. Okay, we have done similar steps for hurdle sensor. In AD mux, we have made a AV with external capacitor and a reference pin and selecting fourth channel of ADC. And then we have pre-scaled or clock to 1 by 128 and enable the ADC and enable the interrupt of ADC. Then we have displayed hurdle distance, and then we have start the conversion as we have done in temperature sensor. Then we have stopped here until our conversion is completed. If we check that if our flag is value 1 in ADC-SRA is and ending the one value with ADC-SRA pin 1. If that value is 0, while this value will be 0, we will stop here, and if that value will become 1, and that value will only become 1 if pin ADIF pin of ADCSRA is 1, and if that pin is 1, we will come out of this while loop, and after that we will clear this interrupt flag of ADCSRA, and then the value which we get from this hurdle sensor, we will convert that analog value into digital integer value, and by using ITOA function we will convert that integer value into character array of 10 size. Then we'll display that value on LCD, and then displaying its unit, and with some delay we will clear the LCD, and after that we will check that if that hurdle value is less than or equal to 10 is less than or equal to 10, then we will stop our robot. By this, if our robot hurdle is near to our robot, then our robot will stop at that particular point. That's all for our code. Now we will move on to our simulation to check how our simulation is working. If we run the simulation, we will see that our right IR sensor and center IR sensor is 1, then our left motor is running, and if we make all 3 sensors 1, then we will see with some delay, then we will see that both of the motors are 0, and if we will make our left IR sensor and center IR sensor 1, then we see that our right motor is running, and if we will make both the sensors and all the sensors 0 and only center sensor is 1, then with some delay we'll see that both the motors are running. And here we can see that temperature sensor is 36, and our LCD is also showing temperature 36 Celsius. This is our hurdle sensor. Right here has our hurdle sensor, and this is as temperature sensor. Now if we will see we see that this is hurdle sensor, and if we will increase the value of the potentiometer, we will see that our motors stops is working, because the distance of hurdle is 4 units, as we have placed if condition, if hurdle distance is less than 10, then our motors will stop working. That's all for our video presentation of this simulation. Thank you.